Sachs.
Okay, so I guess I really am the outlier here because I didn't get to raise my hand when they were asking about who was here. I'm an educator. I chair the Department of Administration, Rehabilitation, and Post-Secondary Education over at San Diego State. And we had this opportunity. Do you have the clicker? We had this opportunity for the educator to meet the clinical neurotech, as we kind of called Eve.
And can I ask how many clinicians are in the room?
Oh, I guess we're both outliers. Oh, okay. Yeah, thank you. So I come at this whole area from a disability perspective. I work in the rehabilitation area, started out as a teacher, a special education teacher, moved into the rehabilitation counseling area, and this is our institute, which was recently sold, but we still have it. It's just in a different location. But I had the opportunity, the co-director of the institute with me, we had gone to a conference on universal design in the early 2000s up in Montreal. And we started thinking about this in terms of the relationship to disability access, looking at disability. We teach from the disability as a social model aspect, disability as part of the human experience. And so we were looking at how can we make our building more of a universal access kind of place? How can we model it for the community? We started bringing in partners in the community to work with us at the building. And so we got really inspired after meeting some folks in the universal design area, came back to San Diego, and who's the first person we meet to talk about this is John Eberhardt. So this was very timely in trying to learn how all of these things were starting to come together around universal design, around what he was doing in the neuroscience area. And then he introduced us to Eve, and we started looking at, wow, how can we engage students in this process? Because I have to tell you, and don't repeat this anyplace, but our university foundation, in coming to us with a design, because they thought it was a good idea, they were ready to fund it, the design they gave us was sort of slapping a ramp on the back of the building. It just wasn't what we had in mind. So kind of switched gears and got to find out what Eve was doing at the New School of Architecture at the time, and trying to figure out how can we work together in making this 10,000 square foot addition a reality.
And
oh, you need your little...
I need a lavalier, but I'll stand on my toes. We can do that also. Isn't technology wonderful? Exercise. If I move, I may remember what I'm about to say. You know, I want to respond to Michael's challenge and talk not only about pedagogy, but also practice, and to talk not only about neuroscience, but its integration into real practice. And this was the opportunity that Caren and I were faced with, a class of students that were learning about neuroscience and thinking about application in architecture with a real-world project, with real people who were saying to us, you know, we're not satisfied with having our safety zone be behind a 4-hour fire door. That makes me very uncomfortable because I'm a quadriplegic. Who is going to take me out of this building? We're not comfortable that our entry into this space is so far away from universally equitable. I have to go around the back up a ramp that in fact the facilities director called a scab on the back of the building. So when we talk about universal design, we're talking about a universally equitable experience of built space for all peoples. Now we asked about who was an architect, who was an educator, who was a clinician. How many in the room are aging?
As we speak.
As we speak. And so all of us are changing dynamically, unfortunately, not always for the better. And so our biologies are changing, adapting, our plastic. And so this gives us an opportunity to take environmental psychology, perhaps Maslow's theory of our essential human needs, and what I did with neuroscience and architecture was turn it on its side and say, let's make this a feedback loop. Let's look at building the physical environment as our input and break down the human experience in these responses from the physiological, the body, through its movement, through its emotions, through its cognitive and creative efforts, and understand that every aspect of design that we change is going to iteratively and feed back onto the responses of the brain, body, and building. So whenever we make a change in acoustics, if our material changes our sightline, then we have to think of a material impacting multiple senses, multiple emotions, our cognitions, and our behavioral output. And so I created this strategy for helping the students to break down their thinking into parts and then to go and look for the neuroscience that supported a design decision. And we looked at this for able-bodied, normal subjects, and we looked at it for people with a series of conditions, and with collaboration with Caren, her colleagues, and her peers, we brought into this class more than a person using a wheelchair, more than asking a student to sit in a wheelchair for 1 hour and think that they might understand empathetic design. We created a pattern of iterative, repeated interaction with people with a very broad spectrum of needs and functions, and then help the students to understand how each change in design fed back onto the other senses. And so I'm also one of those people that's answering Michael's questions. My PhD in neuroscience began in hearing science. And, you know, hearing scientists carry a big chip on their shoulder because vision science is understood, and hearing science is saying, but wait. When we walk through a building, we hear it whether we recognize it or not. When we function in an operating room, if you can't hear the difference between adrenaline and aspirin because of the acoustics of the space, the patient might die. So there are real changes that we can make on the basis of how we understand each cell works within the cochlea, within the eye, within the cortex. And so some of what we're going to talk about is how we took all of this together, taught a series of students in a series of classes, and ultimately how we translate this into real built design. Now, admittedly, when we look at it, we see design, we see neuroscience interpreted and translated into design features. And so we have to make leaps. But just as we don't know everything about diabetes today, we actually know enough to make a huge impact. Just as we don't know everything about the influence of architecture on our brains and bodies and behavior, we still know enough from existing clinical literature, existing educational literature, to make a huge impact. And so teaming with a number of different universities and colleagues, this is David Kirsch, as you can see, very active with his cognitive science class of ethnographers that our New School of Architecture students teamed with. And the ethnographers were tracking information flow and cognition in the radiology read suites at University of California hospitals to try and understand information flow. The architecture students were tracking the ethnographers because they very rarely get exposure to this degree of observational skills. And so I wanted the architecture students to watch how people being trained in ethnography learn what the user wants. And then I took my architecture students, not the cognitive science students, into the CAD lab and turned on the National Library of Medicine PubMed. And said, now we're going to learn how to search for the reduction of error in radiology reads based on published research that looks at brightness and contrast in reading an image. And we found data that even the chief and other practitioners in neurology imaging suites had not read. And then I told them, design me a 30 by 30 space with every technology you've seen at Cal IT that could advance how radiology is read today. And they were able to not only bring in what they learned from PubMed, bring in what they learned from cognitive ethnography, but build it in a cave, stand inside of it, and demonstrate as we move through the space that the volume of space was workable, whether or not I was sitting at one desk and trying to focus and concentrate on what I was looking at, or receiving grand rounds, or working with a small team of interns. So again, in pedagogy, we went from detailed data, neuroscience, critical analysis of what we could translate and what we shouldn't translate into an aspect of design. Some of our students at New School went on to win awards for going beyond the universe of design, and this is actually a thesis project that looked at the design of space stations. He wanted to be a space architect. And using my background in vestibulo-ocular and the balance system, I guided him to how he might change the symmetry of his design for a space station to give the astronauts a sense of vertical and up and down by visual means, not just physical means. There is no gravity. They needed this information from science. And so our goal is to introduce user experts to change design thinking, to introduce our students to people with multiple sclerosis, to people with hearing impairment, visual impairment, motility impairment, the broad spectrum of impairments, to change design thinking and use neuroscience and architecture and universal design as steps in the architectural process itself.
So back to INTERWORK. This was one of the designs that the students came up with in looking at some of the various needs that we wanted for our building, in building community, in providing that access so that when you were walking in the building and you had somebody who was walking and somebody who was using a wheelchair, that you didn't have to go two separate ways to get to the second story, that you could go together up a ramp and not split up. And so we came up with, the students were great, and what they got to do before this was they actually got some foundation around disability, around this whole social model. And then they got to spend some time meeting people and talking to people who had needs that sometimes competed with each other. You know, if you have, I have a colleague who's blind, who went blind after a medical incident, and her needs are very different than the other student that I brought in who's hard of hearing, and another student I brought in who had a spinal cord injury. So they got to know them as people and started having some very personal conversations with students, which was really exciting because they started seeing things differently. They started moving from that compliance, oh, I got to check off this ADA box, to how can I think about how Holly uses this space? How can I think about how Chris uses this space? So we did that. Then the next round, we had another group of students, and we wanted, again, to expand. Eva was continuing to expand what she was doing in the neuroscience area. I come at it from, I actually have a background in assistive technology, so some of these pieces are starting to cross over for me. I'm making new synapses here. Thank you, Terry, for helping me to see how all these things connect. It's really, my brain's about ready to explode after a couple of days here. It's a little too much, but it's really exciting because I work with people who design smart homes, and I work with folks, you know, who are getting all this technology together to support people. So then the students got to meet another colleague of mine who has MS, and building in not only her MS, which changes, it's a progressive condition, but also looking at her background. She's from the Middle East, so we're talking cultural backgrounds, and they were really able to start doing some research to find out how do you put all these pieces together in redesigning her house, which had recently burned down. And in doing some post-surveys with the students, we found out it really was making a difference. And there's just a few of the comments. This course has greatly influenced my mindset of architecture, the hardest part of architecture, understanding how we experience space now makes sense to me when approached medically. 4 years of architecture and it all just clicked. Don't we love to hear that as educators? And so we had them rate kind of the usefulness of getting this information in different ways, the time that they spent in connecting it with what they were doing and how they really integrated that into their design thinking and into the designs that they actually created. Fast forward.
Fast forward another couple of years. So what you're hearing is an iteration of different courses that we played out over about 10 years. Continually developing this program. And then in 2013, I was invited to join the Berkeley Prize Teaching Fellowship to advance universal design. And this set of fellows span from Uganda and India to the US and Glasgow, which I think is still in the UK. And what they were interested in, particularly from the contribution that we made, was to take the neuro-architectural process where we thought about brain, body, and behavior, and use universal outcomes as one of the metrics of the success of a design. So the combination of these two things, and not to forget that outcomes are measured in return on investment, and our focus is return on investment in human outcomes. And so our intent was to have an international, interdisciplinary, intercollegial interaction. And what we found were a series of very important principles. Peer-to-peer was our principle, and it was essential. We incorporated peer-to-peer in our students. We had wheelchair users in our class. We had students with visual impairment, students with auditory impairment, students with learning disabilities, all together in the class, learning architecture differently. We also had a faculty with different concepts and different needs. But our students, again, showed a very high acceptance of this pedagogic model of helping them to think about design differently and changing their mindsets. We saw students positively responding to this concept in such a way that it's unlikely they will ever go back to a different way of thinking. Universal design, neuroscience, is no longer an add-on. It's no longer an afterthought like ADA used to be after you designed the building. Much broader and deeper and more sophisticated considerations were in their open answers to comments, and we saw them ingrain this in their student projects. So here's an ARID project with ramp. I call ADA ramps and rails around toilets, but universal design goes beyond that. And we started them thinking about the sensorial experience and combining acoustics with visuals, with movement, using things such as circadian light to draw a path, recognizing that some people with visual impairment or cognitive deficits would not understand brightness and contrast on the ground if it was not used carefully. Even the Canadian Ministry of Health has incorporated some of these recommendations in their request for proposals, asking us to think about specularity as it relates to seizure, and as it relates to landscaping and floorscape, and lack of confusion of people with cognitive or other sensory impairments. And so we're seeing our students incorporate these concepts also in their designs. What was most rewarding to me was one of my wheelchair user students, and I was very frustrated that I hadn't made as much advance in this as I wanted to. And this was his comment: "I can assure you, you have had great impact." He had been with this cohort of students for 3 years, and yet as a result of one semester, he saw huge impact in the way his peers thought about design. Faculty adoption has been more problematic. Oh, are you surprised? I'm sorry. I was asked to restrict my lecture on neuroscience and architecture to 1 hour. And of course, they were constrained. They didn't have time to teach about human responses in addition to creating a building. And could I just give them a list of all the neural responses to design? And I said I would be very happy for them to take my courses that span 3 or 4 semesters to do that. But in the meantime, we should work together. And yet, after 2 semesters, their responses changed. They recognized the importance of involving user experts, and that this is no longer to be considered an add-on and a much more sophisticated set of thinking than a series of checklists. So to me, this was a success.
And I know we're about out of time. This is just kind of our next area of really looking at, we need to be more intentional about how we introduce this innovation around universal design, and that it's more than just saying it's a really good thing and there's all this research to back it up. As we know from recently, the NSF came out with a new kind of innovation core that they're funding to try to span the ditch of death, is what they're calling it, from research to practice. So in an effort to try to fill in that ditch a little bit more, really looking at the individual motivations for adopting it, looking at the readiness of the organization to adopt these new practices, and trying to be more intentional about that. We'll just kind of move through that importance of the peer interaction, looking at faculty to faculty, student to student, and then the user experts really being there to inform it, and doing it across cultures, different populations, and understanding that we have to change the design process, that we're not out to change individuals and saying you have to change to do this, but looking at the bigger picture. And part of then what we're doing, and I've heard this bring up, and Michael really emphasized it today, is this idea of collaboration and this transdisciplinary collaboration. People need to be taught how to collaborate. It's not that easy. We can't just put people in a room and expect that they're going to talk together and figure out the language. That's part of the reason I came here, is I need to understand the language more. I need to understand some of the research and how that can get applied to practice. And I can't have those conversations with Eve without understanding more of her language. And we don't do that. We don't cross those boundaries and teach each other our languages. I have a certificate of rehab technology that I created with our College of Engineering. It took me a long time to figure out how to communicate effectively with the engineers. We talk very different languages, and we're getting better at it. So I think I really applaud what was said here today, and I think we have to be better at teaching those skills if we're really going to see that seam get seamless.
And apologies for the spread of this, but in teaching this transdisciplinary thought, we were very surprised when we received EDRA's petition that responded to the new NAB criteria. And you will see that the new proposals remove the condition that is to be taught to students about understanding human behavior, absent 2014, that help them to understand a responsibility to public interest just at the moment when the concept of creating healthy cities and healthy planning and healthy architecture has come to the fore. Again, this condition is now dropped from accredited programs. And then the deeper understanding of the application of research and the impact of design on human outcomes, again removed. And so what is it that we can do as this community of practice to bring it together into real built design. When you leave here, you will see the new Jacobs Medical Tower being built, and it looks just like this, even though this isn't a rendering. We made significant changes as a result of understanding the neuroscience of neonates, newborns, and noise-induced hearing loss relative to the location of the helipad on that roof. We changed where the babies were because their ears were more sensitive, undergoing these ototoxic medications that were required for their health and wellness. This is the Ed Roberts Center, real built and beautiful design that serves all people. This is circadian design based on the neuroscience of the ganglion cells that we discovered in 2001 that tell us how the eye interprets time and changes our physiology and our cognition and our mood. This is a tiny school also built where this specular surface was of risk for those with autism, but the exterior place was to help teach students with mobility disorders. And finally, a 2.4 million square foot hospital campus in China built today. And that fracture through the center is both a respect to culture with the icon of the red circle, but circadian light brought in for whom? Not just the patients, the staff who spend decades inside the bowels of our buildings. And so we're seeking to serve everyone from the most fragile to the most gifted, and interpreting what we know from neuroscience now into those design principles that can be built while we do no harm and potentially do great good. So, one of our comments from a student that won the award that we gave for our studio from the Berkeley Prize. And she's convinced now, and I'm convinced too, that all of us in this room can create real buildings that change the world. So thank you.